as we heard Teacher Yolanda give us our recap, we have been doing relationships. We've looked at what are relationships between different variables, how do variables relate to each other. And so now, today, what we're going to be doing is we're going to look at ways that we can represent those relationships. So when we talk about represent relationships, what we're actually talking about is we're talking about how can we show people this relationship? How can we show it in a picture or in, as here you'll see, in our tables, in our flow diagrams, equations, graphs. So that's just graphically representing our relationship. So it's showing someone, this is my relationship, and here's it all set out in a lovely little table for us. So that's what we're going to start with today. We're starting with tables. So when we use tables to look at our relationships, we learned, what did we learn? We learned about input variables and we learned about output variables. So when we're using tables to represent our relationships, generally what we do is our top column over here will be our inputs, because that, again, what we learned, that is our independent variable. So generally what we want to do is we want to have our, sorry, I'm seeing someone saying they can't hear anything. I hope everybody else can hear me and I haven't just been talking to myself.
Yes, no, we can hear you. So everything is fine on our side. I think they just need to connect to audio. Don't worry, I'll be responding privately to them. So you can just continue.
Thank you. So we learned that our x values are our independent variables. What does that mean? It means that our x value doesn't depend on anything. It can stand on its own. So when we're doing our tables, we always want our independent variable on the top. We want that first, and that's usually what we call our x variable. Then our y is what we have in the bottom. That's our dependent variable. What does that mean? It means that our y values depend on whatever our x's are. So whatever we put into our x values, that will give us our y values that we're going to get out. So let's look at the actual question now. When we look at the question, it basically tells us fabric costs 12 Rand per meter. So let's first look at what is the relationship between these variables. What are our variables? Our variables is the amount of fabric that we're buying, and the other one is the amount of money that we're going to pay. What is the relationship between those variables? I think that the more material we buy, the more meters of fabric we buy, the more money we're going to pay. So that's the relationship between my input and my output variable. So what was my input? My input here is going to be, is it going to be my cost or is it going to be my meters of fabric? I think that is going to be, let's see if I can write in here, meters of fabric. Oh my word, guys, my handwriting, it's okay. So I think my meters of fabric is going to be my independent variable. That doesn't depend on anything. I can buy however many meters of fabric that I want to. And what's dependent on the meters of fabric? What's dependent on my meters of fabric is my cost. And this will be my cost in rands. Oh my goodness. Okay, so now we have my cost in rands and we have my meters of fabric. So let's do our inputs. We have our independent variable, remember, so we can pick any values to be our independent variable. So let's say I buy 1 meter of fabric. What is my cost going to be? My cost is going to be 12 Rand 50. Why? Because it costs 12 Rand 50 per meter and I've only bought 1 meter of fabric. So how do we get my cost? I take my meters of fabric that I'm buying and I multiply it by my cost. And then I get my total cost. Let's look at another example. If I buy 2 meters of fabric, how am I going to calculate that? I'm going to take my 2 meters of fabric and I'm going to multiply it by 12 Rand 50. And when I multiply by my 12 Rand 50, I get 25 Rand. I hope this is making sense to you guys. I think if anybody has a question at this point before I complete this table, you can let me know, just so that I don't carry on explaining and nobody is understanding. Okay, I'm not seeing any hands being raised, so I'm just going to continue. Let's see in the chat, can someone give me another number? Let's pick another number for our x values. Anybody pick a number? Let's make it easy for our calculation's sake. Let us try and pick a number between 1 and 10. Okay, 4. We have 4. So let's make my next number 4. If I am going to be calculating my cost of buying 4 meters of fabric, how am I going to calculate that? Let me just scroll down a little bit. How am I going to calculate that? To calculate this cost over here, what am I doing? I'm taking my 4 meters of fabric, I'm multiplying it by my cost, and that is going to give me 50 rand. Okay, let's look at some more numbers that we have in the chat. We have 7. Let's go with 7. If I'm doing 7, I'm doing the exact same calculation the whole time, guys. It's going to be 7 multiplied by 12 rand 50, because that's my cost per meter. If I put in, let's put in, what's the next number? The 10. And let's go with, let's see what the last number is. Okay, 21. Let's go with 21 over here. So can somebody do these calculations for me? I do not have a calculator in front of me. I do know though, this one is going to be, I'm multiplying 12 rand 50 by 10. So this is going to be 125. I'm seeing 87 rand 50. I'm assuming that's going to be for this, 87 rand 50. Well done, you guys. I love to see the participation. And can someone give me the answer for the last one? How much am I going to pay if I buy 21 meters of fabric? 262 rand 50. Thank you guys so much. You guys are superstars. 262 rand 50. Okay, I hope that makes sense to everybody, and I hope that you can see how we've now represented our relationship inside of a table. So what did we do? Let's recap quickly. We have my independent variable on the top. We know that my independent variable is usually our x values, and we have my dependent variable at the bottom, and that will be my y value. How do I get my y values? I take my independent variable, which was my x variables, and I multiplied it by my fabric cost to get my total cost. I hope everybody is happy with that. Let us move on. Still no questions, I'm assuming, because I see no hand. We are moving on. Okay, so now we see a difference.
Sorry to cut in mind. I just want to get it right. So my peps, you don't have any question? Did you understand? Please give me some thumbs up on the chat. If you didn't understand, if you didn't understand, just choose a thumbs down. Let's see. Let's go. Yes, I can see those thumbs up. Let's go, my peps. Okay. Okay, Teacher Simone, we are good. We are good to go. Well done, my peps. Well done, my people. I'm so proud of you. Okay, we can move to Teacher Simone.
Okay, moving on, we have now a pattern. What we know is we can label our pattern. So immediately I want to go pattern number 1, pattern number 2, and pattern number 3. So my question is asking me, describe in words how this sequence is generated or made from term 1. So this we've also done before. We've done description of patterns in words. But you'll notice something a little bit different about this one. If I look, how do I get from here to here? What did I do? I had to plus 2. And then to get from number 2 to number 3, what did I have to do over here? I had to, I see the answers in the chat, great. And well done, I see n, add 3. Great. So now we normally know when there's a constant difference, it's easy to describe our pattern. We can just say to get to the next term, add 2 or add 3. But now we don't have a constant difference. So how exactly am I going to describe this pattern in words? I did not add 2 every time because look at the first jump. In my first jump, I added 2. In my second jump, I added 3. So we're not adding 2 every time. But what I can say is that to get to the next term, what did I do? I am adding consecutive numbers. Can somebody tell me what consecutive numbers are? You can put it in the chat if you guys know what consecutive numbers are. It's not consecutive odd numbers. Why is it not odd numbers? Look at my first jump. My first jump was a 2. Is 2 an odd number? No, it is not. So you are correct in adding consecutive numbers, but they are not odd. They're just consecutive numbers. So I added consecutive numbers, but look at what I started with. I started with 2. Oh, and I missed out my will. So let's, here we go. Starting with 2. So what does that mean? I didn't see anybody telling me what consecutive numbers are. Consecutive numbers are just numbers that follow after each other. So if I ask you what are consecutive numbers after 2, it's going to be 2, 3, 4, 5. It's normal counting numbers. So when I say I'm adding consecutive numbers, I just mean I'm adding consecutive numbers. I'm adding numbers that plus 1 each time. You could have also explained this relationship like that. You could have said to get to the next term, we add 2 and plus 1 each time. There are different ways of explaining relationships, so you just have to make it make sense. And as long as you're saying the right thing, you will get your marks. Yes, I see numbers continuously follow each other. You guys are 100% correct. So I hope this makes sense. So what are we doing? We're adding consecutive numbers. I started with adding 2. Next, I added 3 to get to pattern number 4 over here. What would I have done? I would have added 4. Why did I know I had to add 4? Because 4 is the next consecutive number. And if I were to draw this in very small, because I don't want to take up too much time doing it, we're going to act like my circle was so pretty and so beautiful. That would be my pattern number 4. And how can you tell that I added 4? It is these 4 that I added on the end over there. Okay. Now we are doing the same pattern, but what I want to do is I want to complete it in this table. So let me see if I can possibly move this up very quickly. Oh no, my table is not together. Okay, let's move it here. Let us first try doing this. What do we know about patterns? I know that I have a TN and I know that I have an N. My TN is what? My TN is let me see if I can give, from that 6 you added 4. Yes, you are right. From the 6 that I had over here in pattern number 3, I am adding 4 and then I have a total of 10 over here. Okay, so in my table, we're talking about TN and we're talking about N. I'm not seeing any answers in the chat, so let me go on ahead. My TN is my term number, and my N will be my number of dots. Teacher Yulinda, just confirm with me that I have the correct TNs and Ns over here, that I didn't swap it around, please.
Okay, no problem. So we are describing in words how this sequence is generated or made from, because you are completing the table now, or we still on
Yes,
the
I'm completing the table.
We are completing the table now.
I'm talking about which with a T in and N, where they're gonna go inside my table. Ooh, what did I do now?
Yeah. So the term number is the one that you are actually getting outside. So the term number is normally our Y, and the number of dots of what we are putting in is normally our X. So N is normally at the top, and then the outcome is normally at the bottom. So yeah, right, yes.
Okay, cool. So again, what did we say, everybody? We have my X at the top. My X is my inputs. My Y is going to be my output. Let's think about this, what we just said. X is my independent variable. What is independent in here? Is my term number independent, or is the number of dots independent? I think that is going to be my term number. Why is it my term number? Because I can pick any term number that I would like to, and that is my term number. But my number of dots will depend on my term number. So if I pick term number 1, the number of dots that I'm going to have is going to be 1. And if I'm completing this table based on the pattern that we have here, in term number 2 over here, we have 3 dots. So let's complete that. Term number 2, we have 3 dots. Let's look at term number 3. We have 1, 2, 3, 4, 5, 6 dots. So let us start that in there. And my little lovely drawing of term number 4. Let's look at that. Term number 4 we counted has 10 dots. If I were to carry on with this, let's go term number 5, term number 6, and term number 7. Let us look at how I would be able to calculate this. I know from here to here, what did I do? I added 2, there I added 3, here I added 4. So from 4 to 5, what am I adding? I'm adding 5. From 5 to 6, I'm gonna add 6. And from 6 to 7, I'm adding 7. How do I know that we did that? I described my relationship in words. I said to get to the next term, I'm adding consecutive numbers, and I started with 2. So here you can see I started with 2, and now I'm adding consecutive numbers. Plus 2, plus 3, plus 4, plus 5, plus 6, and plus 7. I hope everybody is with me and that this is making lots of sense. So let's fill in our missing numbers. Term number 5, we're going to have 10 plus 5, 15. Term number 6 is going to be 15 plus 6. That is going to give me 21. And lastly, for term number 7, I'm starting with 21 plus 7. I'm going to end up with 28. Okay. So this was basically our looking at how do we represent relationships in tables. We have now completed our table section. So if there is something that you guys don't understand at this point about tables, please let us know. Raise your hands if you are all good. Put a thumbs up or your favorite emoji in the chat so that we know where you guys all are. I see a thumbs up. Thank you, Morgan. Great, lots of emojis. I see no thumbs down, no hands. Let's move on. You guys are too smart for me. Moving on, we now have our flow diagrams. Our flow diagrams, very similar to tables, except here, what do we have? Here, my X inputs are gonna go on my left-hand side of my flow diagram. What am I gonna do? The middle tells me what my rule is. So I'm gonna take all of my X inputs, I'm gonna flow it through the diagram, because it's a flow diagram. I'm gonna flow it through my diagram and apply my rule, and on the other side, out comes my Y value. So again, Y value, that is my dependent variable. My answers that I get in here will depend on what I put in the beginning. So let's start with a very basic number 1 over here. And let's do my calculation on this side. I'm going to take 1. I need to multiply it by 2. Once I have multiplied by 2, I then need to plus 3. 1 times 2 is 2. 2 plus 3 is 5. I hope we're all seeing how I got to that answer. So when my input is 1 and I follow my rule of times 2 plus 3, I get an output of 5. My y value is 5. Okay, let's try to set this up a little bit more like an algebraic equation, which is what we know and I'm sure loud. Let's try a little bit of a harder one. Let's try number 3 in there. What I would do is I would say, I'm trying to figure out what is my output value here. So I'm going to say y is going to be equal to 3 multiplied by 2, and then I'm adding 3. I hope this format looks familiar to everybody as well, that you know how I set this up, that you know that our brackets is multiplication. And let us continue. So we have 3 times 2, I'm going to get 6, and 6 plus 3, 9. So my next output value over there is 9. What does that mean? When my input is 3, my output for this diagram is going to be 9. Great, I see some correct answers in our chat. Moving on, let's try 5. I seem to be liking the odd numbers today, so let's try 5. I'll do my calculation down here. What am I saying? I'm saying my y value is going to be 5 multiplied by 2 and plus 3. So I'm going to have 10 plus 3, and that is going to give me 13. Let's try a different number. Let's go with 15 just to spice up our lives a little bit. What are we saying here? I'm saying that my y value is going to equal 15 multiplied by 2 plus 3. I'm then going to get 13 plus 3, and we get a lovely 33. Great job in the chat, guys. I see all your 33. And last one, let's challenge our brains a little bit. Let's try 162. Let's see, I want to see answers in the chat, guys. Help me out. What am I saying? I'm saying my y value is going to equal to 162 multiplied by 2 plus 3. What is 162 times 2? I'm getting 200 and 120, 324. 324 plus 3, 327, and I see you guys all beat me to it. Thank you, thank you, thank you. You guys are too smart. Okay, and there we have our flow diagrams. Now, what I want you guys to see is you also learned about writing out the rules. So when we had to write this rule, look at what I was actually doing. I can write a general rule for this flow diagram by saying y is equals to, and what was I doing here? I was saying that my y value is equals to my x value multiplied by 2 plus 3. Now we know we don't like this format too much when we have x's, so let's change that up. Let's make that y is equals to 2x plus 3. Okay, that is our first flow diagram done. We are going to go through one more flow diagram before we get into our brain break for today. So, and here, this is easy. We have all our inputs given to us. 1, 2, 3, 4, 5. Super, super easy. Help me out, guys. Put your answers in the chat. Let me know if you understand, if you are following. So, I'm going to say my y value. Oh, let's change color back to blue, back to black, I mean. My y value here, by the way, these are my x values, my input values. this is going to be where all my y values are going. I don't know why my pen doesn't like me. Ignore my scribbles, guys.
Don't worry, we are following, Teacher Simone. We are following. No worries. Take your time.
Thank you.
Getting you. My people are understanding. Well done, my people. Let's keep those answers coming.
I see I forgot to take a screenshot while everybody's busy in the chat. Let me scroll up for you quickly so you can take a screenshot of this.
See, my people are already giving the answers for number 1 and 2, 4.
I see. I'm so proud of them. I'm like blown away by how smart they are.
We still need your explanation though, because then we need to correct our work. Because of course we're getting different answers from different kinds of people. So they need more final answers so we can mark. Hey, my people.
Cool. So let's see. What am I doing here, guys? I'm saying that my y value is going to be my x value. So my x value is 1, not 2. I'm saying that my y value is going to be my x value, which is number 1 for our first little branch over here. Then what do I have to do? I have to multiply that by 2. I then have to add 1, and I'm multiplying all of that by 2 again. This looks a little bit confusing. Let us break it down into a little bit of an easier format. If I am saying 1 multiplied by 2 plus 1 multiplied by 2, I'm going to do this. Let's go 1 times 2 is 2, 2 plus 1 is 3, and 3 times 2 is 6. And I see lots of answers in the chat, and you guys all seem to have 6 for the first one. If you're not very good at this, don't worry. We have more examples that we're going through, and we will get you there. Okay, so that was this first one, guys. Well done. I see a lot of correct answers. Moving on, let's try number 2. What am I saying for number 2? I just want to move over a little bit so I can give myself some room to write. Okay, what am I saying for number 2? My y value is going to be 2 multiplied by 2. I'm going to plus 1, and then I'm going to multiply all of that by 2. Why did I put in my brackets here, guys? If I didn't put in my brackets over here, I was supposed to follow BODMAS and multiply 1 and 2 first. So 2 times 2, 4, plus 1, 5, times 2, 10. Let's look at the chat. Lots of 10s in the chat. Great stuff, you guys. Let's look at the next one. Y value will be 3 multiplied by 2 plus 1. And I'm then going to multiply all of that by 2. 3 times 2, we get 6. 6 plus 1, 7. 7 times 2, 14. Let's look at our next one. We have y will be equal to, which one are we on now? 4 multiplied by 2 plus 1. So you guys can see, this is very repetitive. I have the same rule for my entire flow diagram. All that I'm doing is I'm putting in a different input each time, and I'm calculating what are my outputs going to be for each different input. So we're calculating my output over here for my input, which was number 4. If I apply my rule to my input of 4, what do I get? 4 multiplied by 2, which is 8. 8 plus 1 is 9, and 9 times 2 is 18. Oh, and I have not been writing in my answers. 18. And let's go and do the last one at the bottom over here. What is my last number? My last number is 5. So what am I doing? I'm taking 5. I'm applying my rule. 5 was my input. It was my x value. I'm taking my input. I'm going to apply my rule. So what does my rule tell me? I need to multiply it by 2. Then I need to plus 1. And once I've done all of that, I'm multiplying that whole thing by 2 again. I see a lot of 22s flooding in. Let's see. 5 times 2, 10. 10 plus 1, 11. And 11 times 2, 22. I'm not surprised. You guys are correct. Okay, if somebody wants to take a screenshot of this, let me just scroll so you can see that nicely. There we go. And we have earned ourselves a brain break. But before our brain break, guys, this is the end of our flow diagram section. We have now looked at how are we representing our relationship using flow diagrams. Where's my representation coming from? In my flow diagrams, on the left-hand side, I'm showing all of my inputs, all of my independent variables. In the middle of my flow diagram, I have what my rule is. What do I have to do to my input to get to my output? And then on my right-hand side of my flow diagram, I have all of my output values. Are we all with me? Thumbs up, favorite emojis in the chat, please. Scroll up to the previous questions and answers for screenshots. Sure, while I wait for all the emojis. I'm assuming from the beginning. Let's try this. You can get here our first table and our description. That's some thumbs up. Thank you, guys. You guys are so smart. I can't believe I haven't had one question as yet. Moving on, we have our second. Yes,
thank you, Teacher Simone. That's why you're a good teacher. That's why we're not asking questions.
Thank you. I hope the class can agree and that they're just not scared that I'm also fresh meat and they don't want to ask me anything.
Give those thumbs up. Hey, my people. We wouldn't give the thumbs up if we didn't understand. Yeah, we are legit. If we don't understand, we'll tell you we don't understand.
I'm so glad you guys. I'm glad that you guys are getting it. Okay, for those who are taking screenshots, the last one. There we go. And I'm sure you guys have been waiting for our brain break. Okay. Teacher Yolanda, can you tell me how you guys usually do your brain breaks?
Don't worry, they actually have to figure them out. So it's a competition. So basically, you should calculate on your side and I will calculate on my side also on how much you're getting. And then normally Teacher Sam just cheats. She gives me the answer.
Okay, no problem.
The first one to get the answer is the winner of the brain break. Okay. And they're enjoying the joke. Nice, my people. So remember, we are looking for the final answer. I haven't got it. Of course, I always cheat. So now it's the
I actually haven't got it either. I need to get myself a page very quickly.
Let's go, my people. Sorry, I'm also calculating. Okay, and then so that's what? That's you get, and basically let's go, my people. Okay, so
I keep looking at these multiplication signs and thinking they're addition.
oh, my people are so clever. Just Simone already got the final answer.
Oh my gosh, I see. I have been beat again. That's what I get as my final answer.
right is Melanie. Congratulations. So Melanie got it right. Melanie, you can raise your hand so you can explain to the rest of the class how did you get it. You were the first person to get it. And then I see who was the second one is okay, Melanie put it again. The second one, Melanie put it again. Melanie, was just you with the correct answer. Oh, Gabrielle was the second one. And then Melanie again. Who else did it right? Melanie again. Then Angel was also right. Hey, my newbie, I recognize you. And then who else? Melanie keeps on saying, I got the correct answer. Ronewa also got the correct answer. Salu got the correct answer. Apelele answer, right answer. Pretty was correct. Andile was correct. Malvin was correct. Emad was correct. Nice. Kenya was correct. Wandile was correct. Sean was correct. Okay, Melanie, now is your time. I'm gonna unmute you. And you just have to explain to us, and then if Teacher Simone can assist in putting the answers that you're saying. Okay.
Yes.
Ma'am, so I calculated how we got to 30 and it gave me 10. So then the next one I said 10 times 10, which equals 100, and then plus 8, which equals 180. And then the waffle plus another waffle, I added that together and it gave me 16, and then I added I times it by 9, which is 80 for the bagel, and then another
I didn't get that. What was the bagel?
The bagel was 9.
9.
Yeah, and then I calculated the waffle, which was 2, 8, so that's 16, plus another bagel, which is 9. And then I times it by 10, and then I got 196.
Great.
Done. Teacher Simone, we have 2 of the cookies. So that was 16 of the on the first one, where we're saying 8 is 16, because it's 2 cookies, not 1. Tricky thing that Melanie got it right. The last
I see. I did not see that now. I see now. Thank you.
Yeah, no, that's okay. That's okay, Teacher Simone. That's okay. It's because, of course, Melanie is talking, and and Melanie is so fast. I couldn't even follow myself. Then, well done, Melanie. Oh, guys, well done. It's amazing. Thank you so much. I hope you did the stretch. Everyone is okay. To tender, the salad is 2. Yes, sorry. The salad also is 2. That's why we got 196. So the salad should be 20, not 10, because it's 2 salads.
Okay.
Thank you so much to turn.
I was wondering, what do you mean the salad is 2? The salad is 10. And that's 20.
No, we be eating salad. So guys, you know that the first operation that comes is multiplication, right? So basically it's 9 times it by 20 plus 16. Okay. And that's how we got to 196. Okay, my people. Thank you so much for collaborating. Y'all are amazing. We love you, and I hope you did stretch, and then Teacher Simone can take us through to the next round. And we are done. Well done, my pips.
Okay, everybody. This, by the way, we are doing equations now. We are using equations to represent our relationships. This is my favorite section. It's my favorite way to represent relationships. It just makes sense to me. And it's kind of like a riddle to me. It feels, like a story sum. It feels like, I'm trying to guess what's going on. And when you get it right, you're like, wow, I did something. I know something. So I hope that you guys feel the same way about this. I hope that it makes sense to you the same way it makes sense to me. So when we are looking at these sentences, our sentences is describing our rule in words. So what do we have to do? We firstly have to know our English. We have to know what that sentence is telling me about my rule. And I then need to be able to take what they're telling me in the sentence, and I need to be able to put it into numbers to get my rule. So let us look at this. If I have this first example over here, we're looking at A. It says my output value. Immediately, What do I know about an output value? My output values are usually Y values. So they are telling me that my output value is the input value. What does input value usually tell us? It usually tells us that it's X plus 4. So that was just output and input. What we also need to know is we need to know our mathematical terms. What does is mean? If they tell me my output value is something, that means is means equals to, does it not? So when we see the word is, when they tell us something is, we know that means equals to. And then plus, we should all know what plus means. Plus is addition, and 4 is just our good old-fashioned 4. And so it actually, funny enough, just so happens that what I've written on the top there is exactly what my rule is. How did I figure that out? They told me my output value. So immediately I'm going to write down y. What did they tell me about y? They said that my output value is the input. So that means my output value is equals to my input plus 4. Can you see how I interpreted this sentence? Can you see how I use my terminology, my mathematics terminology? I knew that is meant equals to. I knew that plus meant addition. And I figured out what my rule is in an equation over here. So now that we have equations can also be, when we did our flow diagrams over here, we were writing out equations. So once you have an equation, you can take your equation, you can turn it into a table, you can turn it into a flow diagram. And that's why I like equations so much. It's almost like the starting point for everything. Okay, let's look at our next one. That was a very easy example. Next one might be a little bit harder. Let us look at it. They said the sum. Immediately I see sum. I'm going to put a little plus on there. Can I please scroll up? I will do so after I finish this question. They told us that the sum of my input value. What do I know my input value is? I know that my input value is going to be X. So the sum of my input value and 5 is multiplied by 3. Okay, so I've basically written what all my terminology means over here. Let's see if I can interpret that and make that into a equation. So they have told me the sum of, so immediately I'm going to put a little plus. And the sum of what? Sum means plus. So that means I know I'm going to have two numbers, because when I have a sum of something, I'm going to have two numbers. So what are my two numbers that I am summing? Let's look at it. They said that the sum of my input value, I know I've written on the top here, my input value means X. So I have now my first number that I'm summing, the sum of my input value and 5. Okay, so we have the sum of my input value and 5 is multiplied by 3. So this entire sum that I've done is going to be multiplied by 3. And to finish off my equation, what does this mean? What are they telling me? They're telling me that when I do all of that, I will get my output. Yes, I see some correct answers in the chat. I see you swapped your 5 and X around. That's still okay. That is okay. Because X plus 5 is still the same thing as 5 plus X. I hope this is making sense to everybody. I hope everybody understands. If you have questions, think of them quickly while I do these. Can I explain again? Okay, let's do the next example. It will be our last example for the day. Let's look at this. We have the sentence. It's telling me the input value. Immediately I'm highlighting input value because I know that is important terminology. My input value is actually telling me that that's, nope, and look at me giving the wrong things. My input value is not Y, my input value is X. So I know my input values are always going to be my X values. That's just a rule that we use. X is always our input value. So they're telling me my input value needs to be multiplied. So let's use a different color. Now they're telling me I need to have multiplication in my rule. There's multiplication somewhere in my rule. What am I multiplying by? I am going to multiply by 3 and then. So that means after I've done all of that, so let's put a big bracket in there. After I've done all of that, because they tell me and then. So that means after all of that, what am I doing? It has 2 subtracted, which means minus 2. So let's see if I can put this into a nice little neat equation. I'm going to have, they said my input value is x. My input value is multiplied by 3 and then subtracted 2. So I don't have to put brackets in here because I already know 3x. We know we're going to multiply there first. And what does this mean? We've now done, we've interpreted our rule. What were they giving us? They were giving us that is how we calculate our output. And what is my output? My output will be my y values. So here when I said y is equals to, I'm just basically saying my output is equals to 3 times my input minus 2. Can you replace for swapping x and y? Yes, you can, because that changes your inputs and your outputs. And then you'll get different answers when you put that in. Okay, I hope that all makes sense. This last one is so nice and easy for us. Here it says our output value is the input value squared. What do I know here? I know my output value is going to be y. I know my input value is x, and I know squared means I'm going to have a little squared number on the top. So let's set my output value, and look at what we have here. We also have is, which means equals to. So my output, which is my y value, is equals to my input value squared. Is it okay if we don't put the brackets? It depends on the what are we talking about, the equation that you are doing. If your brackets are necessary to show BODMAS, then you would have to put in your brackets like in B over here, because my 3 is being multiplied with my x and my 5. Okay, that is it for today, guys. What have we done? We've done representing graphs, representing relationships, using tables, flow diagrams, and equations. I hope this made sense to everybody. Teaching Elena, what are we doing today? Today is Monday, so we are doing a poll.
Poll, yes.
Okay, guys.
They want to explain B again while they're busy doing the poll. If you can just to them. Yes, please.
Let me go back to B. Let's look at what B is telling us. B is telling us we have a sum. What do I know about a sum? When they tell me I have a sum, immediately I know I need to plus. Now I'm trying to figure out what am I plussing. So they told me it is going to be the sum of my input value and 5. So before we even do anything further, let's write that down. I have a sum. What is my sum? My sum is the sum of my input value. My input value we know is x and 5. That's the first part of my equation done. So here we have my sum. Now my sum is then multiplied by 3, which is why we need our brackets, because it's not just x is multiplied by 3. It's not just 5 is multiplied by 3. It is my sum that is multiplied by 3. So I'm putting brackets around my sum. I'm going to multiply my sum by 3. And my equation is not done as yet because I don't have my output value in this equation. So to finish up my equation, we are going to say my output value is going to be equals to 3 times the sum of x and 5. Yes, our equals to sign is important. I see Linda is saying that. Thank you, thank you, thank you.